Hi, everyone, and welcome back to the Regression and Beyond series. In this next set of videos, we're going to be talking about how to evaluate and address missing data in your regression models. As before, a link to the script file and data I'm going to be using for this tutorial is linked below. So let's jump right into it. So at the start, things that we've all done before, I like to use the Rio package to import data. So in this case, similar to before, 500 observations of 4 variables. Now let's do a summary as we often do at the beginning. And one difference that we see compared to before, we have all these NAs at the bottom showing up. In R, the missing data code is NA. So all these NAs is showing us those are the amount of missing cases for each variable. Now, if you're using a different program or a different missing data code, you might have to change it to NA. And if you want to do that for a whole data set, this is the command that you would do here. So for example, I often use -99 as a missing data indicator. And if you had a whole data set, again, and you named it data, you would just say, okay, everything in there that's a -99, I want you to turn into an NA. So you might have to do that as a first case. In this particular lab, in the data, I already did that, so you already have the NAs in there. Now, one basic thing that we can already look at is the proportion of missing data. Lots of different ways that you could do this, just really simple. Here, I'm just going to do the calculation, right? So for our y, our dependent variable, it's the 124 missing, and we know we have a total of 500. So about 25% of cases have missing values on our dependent variable. Some heuristics have been proposed for like how much missing data is problematic or how much missing data is too much missing data. Generally, it's kind of if you're above 10 or 20%, maybe you're getting in problematic territory. But critically, like any heuristic, it's kind of this general rule that you really don't want to rely on and can vary in specific cases. What really actually matters is not the proportion of missing data, but it's actually the missing data mechanism, or in other words, why you have missing data, specifically on your dependent variable. That's ultimately going to determine whether, for example, you might get biased parameters. So we're going to be talking a lot about that and how to investigate that and then ultimately address missing data. But real quick, I want to note sometimes if you want to do basic things like just look at quick descriptives or something like bivariate correlations, and you do have missing data, you have to add a little line to say that you want to use only complete observations or remove the missing data. So we have missing data on our y variable. So you see here, if I try to just ask for the mean for y, I just get an NA. What I need to add is basically this line that says remove the missing values and then calculate the mean. Similarly, we can do that with other things like a correlation I'll just show here. Just quickly wanted to make that point in case you try to run and try to do a bunch of things and you do have missing data, you do have to basically tell R what to do with that missing data. The taxonomy of missing data mechanisms that we use today comes from Rubin, and there are 3 of them. They kind of had misleading names, but missing completely at random, or MCAR, missing at random, MAR, or missing not at random, MNAR. MNAR. I'll be talking about these a little bit as we go through them. There's definitely a lot to get in with them, but as a starting point, generally MCAR is the best case scenario you want to be in if you have missing data, followed by missing at random, and the worst case scenario is the missing not at random. In principle, you can test whether the MCAR, the missing completely at random, with some important, maybe critical limitations to that for a lot of practical applications of using it. But you can otherwise only assess the plausibility of missing at random. And we'll be talking about, and I'll be showing you how you could do that. And I'll be talking about a little bit more about what these terms mean, and I think you'll see why they're a bit misleading. But to start with MCAR, so it's a little bit kind of confusing to think about or abstract, but you want to imagine the hypothetically complete data. So if there was no missing values, and then we have the data that we've actually observed, right? Well, if your data are MCAR, what that would mean is the data you have observed is a simple random sample of that hypothetically complete data. So in other words, that's where we say missing completely at random. That's actually what we're talking about. It really would be random, right? Because we're using simple random sampling to actually have those observed values. It'd be kind of, in this case, we have 500 observations. If we just randomly selected numbers between 1 and 500 and deleted those cases as we went through, that would be an MCAR situation. So we're going to use a test for this, Little's MCAR test, and you'll have to install this new package, Misty. So you'll do that, and then we need to load it, and then it's pretty easy command. In this case, I'm doing it for the full data set for all the variables. And our output, we'll see the 500. So we already knew that, sample size of 500. The N incomplete, this is the number of cases that have missing data on at least one variable. So about a third of our overall sample has missing data on at least one variable. Of those cases with missing data on at least one variable, there are overall 9 distinct patterns. One pattern, for example, would be cases that have missing data on this variable and that variable, but have complete data on everything else. That's what you mean by a pattern. And then we get the chi-squared degrees of freedom, and then our p-value here. In this case, the null hypothesis is that the data are MCAR. So in this case, we'd have to reject that null hypothesis. So we wouldn't be able to assume that our data are MCAR in this case. You can look into it a little bit more. Check out that help file for the MA test, talking about some of the more problems of it. But one of the big ones you have to consider is that the data have to be multivariate normal. So in the previous videos, I was talking about violated assumptions. That's very common in the real world. So if that was your case here, then the results of the test might not be actually valid, and maybe we couldn't actually use it. And I think maybe a more general reason that you probably maybe don't even need to test MCAR is, I think in the real world, you would rarely expect to have missing completely at random data. Or at least I've never been in a situation where I've had it, and I don't know anyone that's had missing completely at random data. I'm definitely sure it happens out there, and you can actually build it into your design if you plan for it. But otherwise, in general, we often expect that there's some reason behind missing data. That again, it's not just the simple random sample. There's some reason why we're missing data. And that's what we're going to be moving on to essentially next. And that's where we move into potentially that assuming the missing at random mechanism. And one real big important thing to note is that list-wise deletion, or often what kind of a lot of people do, which is just deleting all your missing data before you analyze it, um, is only going to be unbiased if the data are MCAR or missing completely at random. If that's not the case, if you can't assume that to be the case, then you might get biased results. Generally, listwise deletion is going to be the worst way to handle missing data. So, as I'll be talking about as we get into here, there are lots of relatively, and I'll show you one which I think is quite straightforward, a way to implement and address missing data. So if we can't assume that our data are MCAR, and I just talked about why we shouldn't use listwise deletion, the next thing we can do is explore the plausibility of assuming missing at random. Now, it's not the only type of scenario of MAR data, but one common and honestly more kind of ideal situation is when we have some variable that we have observed that is related to missingness on our dependent variable. Or as I mentioned, there's kind of a reason behind that missing data, and maybe we have measured something that can capture that. And a way that we can explore this is we first need to create an indicator, or I'm going to create just a simple dummy variable, a 1 or a 0, with 1 meaning that the data is complete, and in this case it's the dependent variable, and if it's missing, it'll be coded as a 0. That is what the line is doing here. We're adding this y miss, so the missing, and then if it's missing, code it as 1. If it's not missing, code it as 0. Oop, forgot to run that. Yep, so we can see it matches up. It worked out. And next, what we can do is see if any of our independent variables are related to that indicator variable. So we're going to use a type of generalized linear model. We're going to be talking about these models in detail later on. So I'm not going to talk about it too much, but in this case, a lot of people will just call this a logistic regression model. And we have to use it because that indicator variable is a dichotomous categorical variable. But you can see here, basically we're regressing that onto our independent variables. So we can have a look at this, and we see two of our independent variables, x2 and x3, are related to missingness on our dependent variable. If you do happen to know about logistic regression, here I'm asking for odds ratios. Again, if you don't worry about it. I'll be posting videos soon talking about these models. But for now, all we really need to understand is that we have two independent variables that are related to that indicator variable. So this results in a situation where we can at least argue or present a case for why we would assume missing at random. Now, again, it's not perfect, but we can present this case. Missing at random, or this version of it, would be that once we account for our independent variables, the data are MCAR. Otherwise, it's MCAR conditioned on our independent variables. In other words, once we account for these things, we have MCAR data. It's imperfect. We can't test it. It's all about how you argue. And again, by evaluating, if you do have an independent variable or multiple, and especially if you have, good theoretical reasons that you can talk about why they're related to your dependent variable, that can be in a good place to be in for making a case for saying that you have MAR data. So in this case, we can at least make that argument. Again, it's not perfect. It's possible that missingness, the probability of missing this on our dependent variable, is related to our dependent variable itself, which is a very tricky situation to be in. But with this, by investigating it and presenting something like this, we could make the case for missing at random, which can be important because the ways we're going to talk about next, the ways of actually addressing missing data, tend to do pretty well if you have missing at random. They do really well with missing completely at random data, of course, but they often do better with missing at random. Where things can be a little bit tricky is when you definitely have missing not at random data. So that's where I'm going to end this video now. And in the next video, we're going to pick up right where we left off and actually talk about the two arguably best methods for addressing missing data in a regression model, but it's applicable to a variety of models, other models as well. So I hope to see you in the next video.